Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. In last lecture, we have discussed about AVL tree, its insertion cases, rotations, and then we saw the deletion in the AVL trees. And we have seen that how a deletion or a node which which needs to be deleted causes how many rotations and so on. So the worst case of deletion was resultant in performing multiple rotations up to the root level. So one example was given in the last lecture, and there was also one assignment due on your side, and you need to create an AVL tree and then perform the necessary rotations. Once done, you have to delete the two given items from the tree, and that was due on in the form of a video lecture uploaded on your own YouTube channel. Majority of the students they did not responded for the previous lecture, so I request you all that please listen the lectures which are being uploaded, and then respond that you have got the point. We may also hear some news about the examinations which may be scheduled if decided by the university and government of Pakistan. We may have our exams, so please be well prepared and learn the lecture, listen the lectures, what is being taught during this. Okay, so today's lecture is about B trees. B tree is basically another kind of tree in which we will have multiple nodes at a given level, instead of having single nodes at a given level in as we have seen in case of AVL tree and B tree, binary search trees. So B tree is a little bit different than the AVL or by the search trees. We will see how it works and what are the benefits, motivations for using the B trees. So first we will look at the importance of using the B trees, and then we will actually see how we can construct B trees. Okay. These are some of the motivations behind using the B trees. Index structures for large data sets cannot be stored in main memory. For example, we talked about the population of, for example, Pakistan. We want to store the information, so it may be around 20-30 millions of population. So it is not sometime possible to keep all the data in the main memory. So of course the trivial option is to store that onto the disk, on the computer disk, and it requires different approaches to efficiency in order to access the disk. Assuming that disk spins at RPM 3600, one revolution occurs in 1/60th of a second, or somehow 16 millisecond. Roughly speaking, one disk access takes about the same time as 200,000 instructions to be executed by the computer system. Means to say that it will take to access one time the disk equivalent to the 200,000 instructions executed by the computer system. For example, on the one hand, if the computer executes 200,000 instructions in the same time, or in the equivalent time, it will access the disk one time. So what we need to do is, or the requirement to optimize the time is, that we must have as minimum disk as access as we can. Okay, so assume that we use an AVL tree to store about 20 million records. Let's say this is the for example, we say the population of Pakistan, for example, and we want to store the information related to the persons in an AVL tree. So what will happen if we use the balanced tree? We will end up with a very deep binary tree with lots of disk accesses. For example, if we have let's say some number n number of nodes, and of course the level will also be keep on increasing, so we may have many branches, many levels in the AVL tree, because we are storing one node at one level. So it could result into log 200,000, which is about 0.2 second in order for the single access to the disk. We also we have seen and we know that we cannot improve the log n lower bound, which is the lower bound on search for a binary tree. We had seen that search operation takes log n time in order to search a single node, a given node in the binary tree, and that cannot be further optimized if we still use the binary tree. So but the solution could be one of the solution could be to use more branches and thus reduce the height of the tree. Means we can instead of having two branches and a single node at a given level, we can come up with some way that can increase the how we can say the number of nodes at a given level, and also we increase the number of levels like from 2 to 4, 5, 6 and so on. So as branches increases, the depth of the tree will be decreasing. For example, if we have 2 branches in a given tree and 10 depth, for example, on the other hand, if we increase the branches from 2 to 5, then the height of the tree may decrease from 10 to say 5. Okay, so that's it. That is the point where the solution or the need of a B tree comes out. So here comes the definition of a B tree. A B tree of order m. M is some number which is for m way tree, that is a tree where each node may have up to m childrens. Like for every single node, it may have up to m nodes, in which the number of keys in each non-leaf node is 1 less than the number of its childs. Keys, for example, this one, let's say this is a node and it is having, let's suppose 3 values. फर्ज करें हम कहते हैं जी 2, 10 and let's say 30. So this could be one node in case of the B tree. So the number of keys in each non-leaf node is 1 less than the number of its children, and these keys partition the keys in the children in the fashion of a search tree. Like it would look like this. For example, it would be having this 3 node non-leaf node. It could have 4 childs, and of course each child would have number of nodes in it, like this one. So this way it could grow up. All the leaves are on the same level. So remember one thing, in this B tree, while we will be constructing the B tree, all the leaf nodes will be on the same level, You may remember this was somewhere we have already studied in one special kind of binary search tree. We have the leaves at all the leaves at the same level, and we gave some name to that special kind of binary search tree. So you are requested to write the name of that binary search tree with your attendance. So all non-leaf nodes except the root have at least m by 2 children. So whatsoever will be the non-leaf nodes, for example, if we consider this leaf node and there may be some root nodes at this point, so all the inner or non-leaf nodes like this one, they must or they have at least m by 2 childs. The root is either a leaf node or it has form from 2 to m children. जो रूट नोड होगा बाइनरी बी ट्री के अंदर, it could be a leaf node itself, like the only node we have in our tree. Then it could be a leaf node. For example, if we talk about a three-way structure, so in that case maybe we have say 3, 5 these two values. So then this could be a this is a root node as well as the leaf node, or it has from 2 to m children's. If it has some children, it should have the minimum number of children 2 and maximum to the number m. We will see how it works. A leaf node contains no more than m minus 1 keys. So whenever there is a leaf node, it will have no more than m minus 1 keys. Keys are these values. We are saying these values, the given values in the particular nodes, these are called the keys. Okay, so the number m should always be odd. So we are constructing a m-way tree, and there is a condition that this m should always be odd. It could be 3, it could be 5, it could be 7, and so on. So it should be an odd number. Okay, let's look at this example of a B tree in which we can match the definitions which we just studied in the previous slide. One is that all the leaf nodes must be on the same level. For example, in this tree, we try to identify the leaf nodes. So we can say this is the leaf node, this is the leaf node, and this is also the leaf node, and same is for these nodes, this one and this one, this one. Okay, so if we calculate the level of these nodes, so 0 and 2, these are at level 2, so this side 0, 1 and 2, so they are also at level 2. So all the leaf nodes are on the same level. This is order 5. Order 5, that is m is equal to 5 in this case, as we have seen in the previous slide that it is a 5-way tree. So each node, it should be having minimum m minus 1 key, each leaf node from 2 to m minus 1. So as soon as it reaches to the level of 5, some node, it will be broken up and further nodes will be created. We will see in the next couple of slides how it will work. So this is a simple example of a B tree. Okay, now we look at that how we can construct a B tree with the given data. Suppose we start with an empty B tree and keys arrive in the following order. This one, the value is 1, 12, 8, 2, 25, 5, 14 and so on up to the value 45. We want to construct a B tree of order 5. For example, in this case we are given with this value, which is defining the dimension of this tree. So m is considered to be 5 in this case. It means that no single root will be a node will be having 5 nodes. As soon as it got the 5 nodes, it will be broken up into different 3 nodes, different we will see how. Okay, so that is all about the supposition for the this tree. Now we will see how we can construct. We will be starting from the values, these values, and keep on adding those values in the tree. So initially it is empty. The first 4 items goes into the root. So first value will be like this. Let's say this is the resultant of adding the 4 values, but I will show you one by one how it will be added. First the value 1 will be added, and then the value 12 will be ordered. So please remember, it will be added in the form of sorted form. For example, the 12 is came in, so it should be after 1. उसके बाद जो value है, that is 8. So logically 8 should be at this point, but once we add this, our algorithm should automatically sort these values. So after adding this, the tree should look like this: 1, 8 and 12. It must be in the sorted. And then we have the value 2. So 2 could be added at this point, but after adding this value 2, our algorithm again it will sort these values in ascending order. So if we sort these values in ascending order, so it will result into 1, 2, 8 and 12. So like this one, okay. So next value to be inserted is 1, 2, 3, 4 and 5, which is this one, 25. So we will see 25 should be added at this point. So the code will check the sorting of this particular tree. So it is already, these values are in sorted form. But once we put the value 25, we can see that now at this level, at this node, we have already reached the limit of 5, order 5. So 1, 2, 3, 4 and 5 values are there. So to put the 5th item in the root would violate the condition of 5. So if this is 5, when it reaches to the 5, we must immediately break this node into further nodes. So suppose if this m is equal to, let's say, 7, then क्या होगा कि we will keep on adding the values and until it reaches at 7. The break will be occur at 7. So same, if we have m is equal to 3, then it should be broken at after adding the 3 values. For example, these 3 values. Okay. So therefore, when 25 arrives, pick the middle key to make a new root. How? This is the node after value adding the 5 values. So this is sorted one: 1, 2, 8, 12 and 25. So once it reaches the limit, we break it from the middle point. So how it will work? This middle point, it will be promoted to the upper side. That is, it will be a root node, and this one will become the left child of this particular node, like this one: 1, 2, and this one, it will become the right child of this one. So it will be having 2 and 12 comma 25. Okay, I hope you understand my point. So this node has been splitted into 3 nodes. The central value has been promoted to the upper side and it become a root node, and this portion has become a left child, and this portion has become a right child. So this will be after adding the value, fifth value of 25, this node and this value causes this split into 3 different nodes like this one. So this is the node which has been promoted from the previous node, and the previous node has been splitted from single to 3 nodes. Okay, next in the same manner we will add the values. For example, we will see 6 is to be added in this one. So as we have seen in the definition of a B tree, these value will be added in the leaf nodes. Once a leaf node is filled, it will be broken up and it will be making the increment of one node in the relevant parent node. So 6 is added in this example. If we say, so 6 will be added to the left, it will be compared to the root node and it is less than the root node, so it goes to the left side. यहाँ पे it will be added in the sorted form. So luckily it is already in the sorted form, so 6 will be added at this point, and it will not cause any split of the node. Why? Because we need to have 5 nodes in a given level or at a given node in order to split that node. Okay, next value to be inserted is 14. So 14, where to be inserted? 14 is compared with 8. So 14 is greater than 8. It means it will be added at this portion. So first, if we see, 14 will be coming at this point. ठीक है जी. After that it should be sorted like this one. So it will be like this. If we sort these values, so 12, then 14, and then 25. So this will be done. 3 nodes has been are there, so this should be rephrased or reordered in this one, and this will become the right child. And of course at this point there will be no splitting, because this is also 3 nodes, there are also 3 nodes, and there is 1 node, and the splitting will be at the 5. Next value to be added is 28. So 28, again we compare with this 8, it will be going towards the right side. So this is the right side. We add this value at this point. After 25 we add 28, this one, and then our code will check whether it is in the sorted form or not. Yes, it is sorted, so this will have no effect on this array. So this version, if we see the clean version, it should look like this one. So 8 is there, left as 1 to 6, 12, 14, 25 and 28, and there is no splitting of the nodes at this point of time. Why? Because there is no level or there is no node which is having 5 values at that node. So okay, next let's say we add 17 in the previous tree. To the right, leaf node would overfill it, so we take the middle key, promote it to the root and split the leaf. Initially we can see that the previous slide, it was having the tree like this, this one, 1, 2, 6, and the right child was having how many nodes? 4 nodes थे उसमें, 12, 14, 14, उसके बाद उसमें था जनाब 25, 25, and then there was 28, the fourth node. Okay, so this was the previous tree. When we added the value 17, so 17 will be added this at this point after 14, like this. There should be one node, we added that value. Of course the same process will be applied. 17 will be added here, then it will sort the node, so it will result into this 12, 14, 17, 25 and 28. So 17 की addition ने क्या किया, it overfilled this node. Like this node now have 5 nodes, so it must be splitted. So splitting का जो mechanism था वो we have already seen that कि जो middle value होगी that will be promoted to the upper side. So what's the middle value in this one is the middle one is 17. So 17, this node will be splitting like this, this portion right side. It will be 17 will be promoted as we did in the case of root node initially. So 17 का जो left होगा, it will be what, 12 and 14, 12 and 14, this one. So this will be in the left, and the right of 17 will be what, 25 and 28. So 25, 25 and 28, 28. Okay, so this will be splitted in the form of this one, and this 17 will be merged with this value. So remember, this 17 will be here, and of course it should be on the right side of this 8, because it will always be greater than the 8. If it is less than it, then it must be on the left side somewhere. So this causes the addition of 17 that was added at this point, and which makes the node overfilled, result into the break of this node. So if middle value has been promoted to the upper side, 18, 8 and 17. 8 का जो left child था, that is 1 to 6 as before, and now 8 का जो right और 17 का जो left है, that will be this one, 12 and 14, and 25 or 28 will be the right child of this 17. So that completes the addition of value 17. Okay, I hope you this is easy and you are getting my points. Now further heading 7, where it will be added. So we compare with this 7 is less than this 8, it will go to the left side. So 1, 2, 6 and 7. So 7 will be added somewhere here. This one, 7 is added at this point, and there is no splitting. Why? Because this is having 4 nodes. So splitting is will be at 5, because we are creating a 5-way tree, m-way tree, which is 5, as we have seen in the previous slides, the value 5. 52. Next 52. So it is greater than 8, it is greater than 17, so it must be on the right side of 17, यहाँ पे somewhere. 28, 25, 28 and then 52. So it will be like this one, 52, and it should not create any splitting of the nodes, because at this point it is having 3 nodes. So it will be like this. This 48 is added later on. So next is 16. So 16, where it will go, 16, it will compare, it is greater than 8, it is less than 17, so it means it will go in between these two values at this path, this one. So 12, 14 and 16. So 12, 14 and 16. So 16 will be added at this point and it causes no split of the node. Why? Because this is again having 3 nodes. Okay, next value is 48. So again 48 is compared with 8. So 48 is greater than 8, it means right side, greater than 17, it means right to the 17. So 48 will go towards the right side of this 17. So 17 का जो right था, this was like this 25, 28, 52. So after adding 48 here, this will be sorted after that. So it will look like this: 25, 28, 48, 52, and that completes these 4 values, adding 4 values to the leaf nodes of this B tree without causing any split. So up to this point there is no splitting by these values. Okay, next we see this adding 68. So 68, where it will be added in the previous tree. If you go back and see the previous tree, so 68 will be added to the right side of this 17. It was I hope it was like this, and 17 का जो right था, there were 4 values. You can see from the previous slide, यहाँ पे 25, 28 and so on. These 4 values were already there. So once we added 68 at the end, that causes this split, and after splitting, the middle value that was promoted to the upper side, and it became 48 became the middle value, and it was promoted to the upper side. And of course left and right of that values has been done as in practice as we did for the previous ones. You can perform the intermediary steps, and please let me know if you have any confusion. So adding 68 causes us to split the rightmost leaf, this one, promoting 48 to the root, and adding 3. After that we add 3, causes us to split the leftmost leaf, this part, because this part was already having 4 nodes. So once we added 3, it causes us to split the leftmost leaf node, this one, and 3 was promoted, promoting 3 to the root. उसके बाद 26 को हमने ऐड किया उसी फार्मूला के साथ. So it was compared with 3, 8, this one. So it is greater than 17 and less than 48. It means 26 will go to the right of this one somewhere at this point. Then 29 again at this level. 53 is greater than 48. So it will go to the this part in the sorted form. 55 go to the this part. So at this time, if we see, adding the value 68 causes a split of the nodes, and then the second split was 3. So John सा भी leaf node होगा, when it is overfilled with the value 5, it will be broken up into 3 nodes. The middle value will be promoted to the upper side, and the left side will become the left child, and the right side will become the right child of that particular node. Okay, so make this tree with your notebook, and next we will add some values. Let's say this one, adding 45 causes a split of, so 45 if we add, for example, in this tree, so 45 is less than 48 and greater than 17. So 45 will be added at this point after 29. So it will be added यहाँ पे 45 in this node. So we can see this has been overfilled. There are 1 2 3 4 and 5 nodes now. So using the same formula, we will split this node into two nodes and promote 28 to the upper side, and 28 का जो left side होगा that will be 25 26, 28 का जो right होगा that will be 29 and 45. But we will see once the value 28 is promoted to the upper side, so it will be somewhere यहाँ पे होगा after 17. 28 will be coming at this point, but you can see that now this node has already reached its limit of 5 nodes, so it means this should also be splitted. It means this will be splitted from this point 17 will be promoted, और उसका जो for example left side होगा 17 का, it will become this 3 and 8. उसका जो right होगा that will be 28 48, and rest of the childs will be managed accordingly. So adding 45 causes a split of this node, and promoting 28 to the root then causes the root to split as well, because root has already 5 elements and we will not be taking more than or equal to 5 elements in a given single node. So it will look like this. The resultant tree, after adding the value in the previous slide, it has broken up that first level first, and then it causes the split of root node, which looks like this: 17 38 28 48, and then the rest of the childs. So that is how two nodes has been splitted, or two nodes has been broken up into different nodes by the addition of some value. So I hope you are getting and you are with me. So inserting into a B tree, attempt to insert the new key into the leaf. If this would result in that leaf node becoming too big mean it is equal to that m value which we considered at the start. If m is 5, so there should not be any node which is having 5 values or keys. So once it has the 5 values, it must be split into 3 nodes. So central value will become the root node, and the left part will be left 2 values will be the left side of that node middle value, and the right values will become the right side of that middle values. So split the leaf node into 2, promoting the middle key to the leaf's parent. If this would result in the parent becoming too big, like the previous slide, once we promoted one value to the upper side, that causes the overfilling of the root node, so we also broke that root node. So split the parent into 2, promoting the middle key as we did in case of the previous structure, and the 17 was promoted to the root level, and 17 के left पे जो था वो left वाली values और right पे right वाली, and rest of the values were organized or managed accordingly. So this strategy might have to be repeated all the way to the top, as we see in the previous slide. If necessary, the root is split into 2 and the middle key is promoted to a new root, making the tree one level higher. पिछली slide में अगर आपने देखा हो, there were before adding that value there were 2 levels, but once we added that 46 I guess value, that splitted the node, promoted to the root, and root was also broken, and the level of the tree has been increased from 2 to 3. It's just in the previous slide. So we can compare that if the same values which we inserted before, if they are inserted into the AVL or binary search tree, then what will happen? It will have it might have a level much deeper than as compared to this newly constructed B tree, which has only 3 levels. And in case of that B tree, BST binary search tree, it may have 10 or 7 8 or 10 levels. So I think that's all about for today. So you are requested to take these data, make a binary tree, and perform the relations where necessary, and send this to me via the same channel where you will post your AVL tree construction example. So this should also be posted by before Monday next lecture. So I hope you got my point. If you have any confusion, question, you are welcome to contact me. Thank you very much and Allah Hafiz.